Okay, this is the last video I'm going to show on how to balance an equation, and there's one little trick I need to show with this one. This one's a double replacement reaction, and what makes this one difficult to balance is the fact that oxygen is in every single compound in this reaction. If I were to try keep track of the oxygens as I usually would, it would become very difficult to keep that balanced. Well, there's a trick I can use with this. I'm going to break up my equation into some larger chunks than I usually do for my table here. You see how SO4 is the same both on this side and this side? That's what's called a polyatomic ion. Polyatomic ions are just groups of elements that stay bound together. And since they stay together in a reaction, we can treat them like one big thing. There's another one in here that does the same thing. This NO3, it's something called nitrate. Because there's both NO3 on this side and on this side, I'm going to treat that like one big thing as well. So here, let me walk through my table and show you what I mean by that. I'm going to break this up into K. SO4 I'm going to treat like one large thing. Ba, and then NO3 I'm going to treat like one other large thing. Now I'm going to tally how many of those I have on the left side and then how many I have on the right side. So looking at my equation, I have two Ks. I'm going to come back to SO4 in a second. I have one Ba, and then you see that 2 outside the parentheses next to NO3? That means I have 2 of this entire thing, 2 NO3s here. You see how there are no parentheses around the SO4? That means I only have one of them. Okay. I'm going to help keep that straight by putting parentheses around that and just reminding myself that, well, there's only one of them. I don't have an extra number around that. Now I'm going to do the same thing on the right-hand side. I have 1K, and like before, how I had no parentheses around the SO4 before, there's no parentheses around NO3 here. So I'm just going to call that 1 NO3. I have 1 Ba. Same deal. There's no parentheses around SO4, so I'm going to put them there. There's no number here, so I'm just going to call that 1. Now that I have my table made, this isn't like a particularly difficult equation to balance. Making the table is by far the hardest part of this. I have 2 Ks on this side, only 1 on this side, so I'm going to put a 2 in front and double everything here. So that means I now have 2 Ks. And 2 times 1, remember there's nothing outside this, so 2 times 1, 2 NO3s. Now my Ks are balanced, my SO4s are balanced, Ba, NO3, everything's balanced. This equation is balanced. So if you see larger chunks that are exactly the same on both sides, you can keep them together in your table like this. It only works, though, if it is the exact same piece on both sides. That's how you balance some of the more difficult double replacement reactions.